Quattro. Okay, there we go. Example 4. A manufacturer of children's playpens makes a square model that can be open at one corner and attached at the right angles to a wall, okay, of the side of the house. If each side is 3 feet in length, the open configuration doubles the available area in which the child can play from 9 square feet to 18 square feet. Now, suppose that we place hinges at the outer corners to allow for a configuration like the one shown in figure 2. So let's talk about the first box. It mentioned a square. Why does it mention a square? How does this make a square? It is. It was originally square. The reason is, can you see how this is now double? Yeah. What if you cut it in half? And remember, this is right now against one of the walls, right, of the house? What happened if you don't and you take this and put it in that side? Would you agree that's a wall? So that's why I originally said you only have 9 feet of plain area. But if you want to make it bigger, just like myself, when I have 3 kids, right? I want it as big as possible, right? So what happened is, hey, you know what? I'm just going to put it against a wall and then make it twice as big. Okay, now using the same thing. What if I have more kids and I want bigger playpen? Notice how they're using the same exact content still. So check it out. This 3 right here and that 3 right there, where did that come from? Okay. Yeah, see, they take this right here. They take that and they make it into the top of the triangle. They take that and they make that into this top of the triangle. So what is happening to this? Is it getting wider, shorter, staying the same? This right here. Cautiously, remember, it says it removes some hinges in order to do this. If it's staying the same, so shouldn't that be 6? Why is it saying X? Can it stay the same?
No.
It can't stay the same. The reason is why?
Because if you just open it, like it won't touch or it won't connect to the top.
Right. If I keep this as exactly 6 feet width, right? Will these meet up? No. That's why this has to be a variation. Would you agree? I can make it pointier or flatter. That's why it's called X, because it's a variation of how wide that is going to be. Are we okay so far of like how this translates to that? Okay. Part A, build a model that expresses the area A in figure 2, this figure right here, as a function of that distance X. Okay, this is a variation between the 2 sides that are parallel. So we know this is parallel. We know this is still what? 3, because that's not going anywhere. Okay. That shape is made out of what? Yeah. Would you agree the rectangle is easy to find? What's the area of that rectangle? 3x. So I'm going to leave that alone for right now. But I'm going to redraw this so it's not upside down, so it's easy for you to see. Okay. What is this side right here? But now that I've turned it correctly. 3. Okay. They're both 3. What is this base right here? X. Okay. Yeah, I'm just taking it and turning it so that way we can see it. Okay. Now that we have that going, I need to find the area of that. Can I go in and draw a height? Yep. Okay. How do I find the area of a triangle? Okay, so the area is going to be, eventually I have to convert it out to X, so it's 1/2 base times height. Is that okay? Can I just go and add the rectangle right now? What's the area of the rectangle? 3x. So the rectangle is all in x's, right? I just have to take care of the triangle. What's the base of the triangle? X. Oh, okay. So that's another piece that I don't need to worry about. Will be okay? What's the one piece that we have to worry about? H. How do I find H in terms of x and only x? It is. It's a great question. Look at the triangle. If the whole thing is x,
It's a right. It's divided into a right triangle.
Good. Can I just use half a triangle? If the whole thing is x on the bottom, what's half a triangle? Half x. Can I use some guy's theorem? Yeah. Pythagoras says a squared plus b squared equals c squared. All right, so let's work it out. Half x squared plus what? Plus h squared equals what? 3 squared, so that's 9. Can I solve for h? Yeah. Let me multiply that out first, okay? That's really 1/4 x. Is that okay? Plus h squared equals 9. So now h squared equals 9, take away 1/4 x squared. I meant x squared. 1/4 x squared. Yay, nay, maybe. Can I take the square root? Do you want to find common denominator first or square root first? Square root first. Now h is the height, right, class? So do I need to worry about plus and minus? No. Okay, so here we go. H equals positive 9 minus 1/4 x squared. I'm going to find common denominator just so that way we can make it a little bit prettier. What's a common denominator? So I have 36 on the top. Take away x squared all over 4. Can I simplify this at all in any shape or form? Can I pull out a factor of 1/4 on the bottom? Yeah. Can I do this? Is that better? Is that okay to do? Okay. Then I have h. Am I done? Call it a day? Go to sleep? All right. Now I'm going to use that to do what? Yeah, it goes right there. Right? It's 1/2 times square root of 36 minus, I forgot, what is that? X squared? Can I simplify that a little bit to make it pretty? A of x equals 1/4 x. Can I do that? Can I make it 1/4 x? Yes or no? Yeah, I can totally. Can I put x over 4?
Yeah.
Sure, whatever floats your boat. Okay. Okay. Am I done? Is my area of this new playpen all in terms of x? Yeah, perfect. By the way, in this problem, what is x? The length of the playpen. You are correct. Okay. Now B, find the domain of this area. What is the length, the smallest length that you can make it? Including or not including? Not including, never, right? I know, you don't even have a playpen. What's the largest length that you can make it and still form an enclosed playpen? You're right, up to 6, not including 6. Okay. What happened when you have exactly 6? What would you make? It would be like that first shape, right? So, yep. Okay. Perfect. We're going to do the difficult piece first, D, and then we'll go back to do C. Can you take out your calculator or go borrow one? Okay, so it says graph A equals A of x. What on earth is A of x? That thing that you find. Normally, it is always that thing that you find. All right, punch it in. Why does it bother to ask us about the domain? How is that useful? The window. You're right. There's a reason it wants the domain, because you need to determine the window. Once you put in x min and x max, what button do we press after? Zoom and zoom fit. And go. You can go bigger or smaller from there, but zoom fit is where you want to start, okay? It looks great. Okay. Is it a parabola? A full parabola? No? Does it go on forever?
No.
No? How come it stopped? Like it just stopped. How come it just stopped? Like most functions, they go on forever. How come this one just stopped? Yeah, look at the end of the radical. Can it go beyond 6? No, no way. Okay. What should we label our graph? The x-axis, that is. Please don't say x. Length. Thank you. What should we label the y-axis?
Area.
Area. It says A. A of x. Area. Okay. Then the maximum out that we go is how many units? 6. 1, 2, 3, 4, 5, 6. I don't know how high the y is because I haven't really traced it yet, but it doesn't go on forever. It looks something like that. Yeah. Now, after you've sketched that out, similar question as we have been dealing with. For what value of x is the largest area? And what is the maximum area? How do I find that? Go find it and then share it with your friends. What was the unit of measurement? That was the feet. Thank you. The largest area is blank feet square when x is blank feet. You fill that in. Okay, check your friends just to make sure you guys are coming up. 2 decimal places is really the rule of thumb if I don't ask you how it around. The largest area is something feet square when x is something feet. All right, the largest area is 2 decimal places. What is it? 82 feet square. 1x is up 5.58. Great. Now look at C. We haven't done C yet. You already have everything you need on that graph. Keep the graph on. Is it possible to find the area when the length is 5 feet? What do we do? Just on the graph. I don't want you to do anything else besides just using the graph one. Yeah, hit second trace. Can you hit that button? Can you find a word that says value? Okay, hit enter on value, and then you put in any x you want. In this case, I want x of 5. So the area when the length is 5 is what? 19.5? 1.5, thank you, feet square. Okay. Isn't that easier? Now you know a second method. Yes, especially like I'm always asking for max anyway, right? Beautiful. I'm done with the lecturing. I'm going to come around and sit